Thank you, Tom. Yeah, I'm from CSIRO, Australia. I work as a principal research scientist for the last 20 years at the CSIRO. For those of who you don't know about CSIRO, which is the largest research organization, federally funded research organization in Australia. So we do research from urban water to medical science to also to atmospheric engineering to climate change. The whole breadth of research is being undertaken as part of CSIRO. So what I'm going to talk about today is the previous speaker talked about stormwater system design and climate change, and I'm going to concentrate on urban water supplies and some of the experiences from Australia with regard to adapting urban water supplies to climate change. I'm not going to talk about climate change projections for Australia. So for Australia, projections are available nationally or for each state and for each season from 1900 to 2100 projections, and for 2030, 2050, 2070. They're all available on the web. So anyone who is interested can have a look at that. So this is the way they provide projections, like colorful graphs, temperature, rainfall, and a whole lot of other parameters. So what it all showing is the most important thing, is the future climate for the continent is warm and dry with very high frequency and high frequency, high intensity rainfall. So that's the overall projection for Australia. And what does that mean for water supplies? So this map shows Australian cities and the states. And as you can see, all of the cities are located along the coast. And for all of these cities, the major water supply is surface water. Except for Perth, the water supply comes from both groundwater and surface water. The city that I live is Melbourne, mainly surface water. So what happens with the climate? With the warm and dry climate, of course, the surface water inflow is going to be reduced. And with regard to water demand, in Australia, garden watering is considered very highly. And open space irrigation and keeping the open space green is considered very highly. So therefore, on average, about 40% of our urban water demand is outdoor water use. So as the temperature rises, so as the demand rises and the supply reduces, of course, then we'll have a supply-demand imbalance. So, we were in a drought since late 1990s. Whether it's due to the climate change or whether it's due to a simple climate variability, we don't know. For some cities, it says that it's climate variability. For some cities, it says that climate change. But whatever it is, since late 1990s, we have been in a drought. The drought just broke now. So what we have experienced, these are observed flows. This is for Perth, inflows to storages in Perth. So the graph is not that very clear, but you can see that there are two horizontal lines. And 1974, from 1974 onwards, there's a drastic reduction in inflows to Perth storages. And the similar thing can be observed for Melbourne as well. So this graph shows the inflows to Melbourne surface water storages. As you can see, from 1997 onwards, there's about a 35% reduction in inflows. So these are historical flows. These are not future flows. So we actually experience the taste of climate change over the last 10 years. And that's part of the climate. And as Tom said, majority of Australians live in cities. So I looked at the United Nations data. It says that For Australia, about 90% of the population now reside in urban areas. And it will increase to about 94% by 2050. So as you can see that majority of Australians live in cities. So therefore, urban water supply is very, very important in Australia. And securing water supply is a major thing. So with the demand increasing, supply reducing, so as I said before, it causes supply-demand imbalance. So this is a graph for Melbourne, which shows that, this green curve, green straight line, is the inflows expected by considering long-term average flows. And the dotted line is the demand. So as you can see that by about 2022, we would expect the demand is more than the supply. And if we consider low flow, which is the high emission scenario, we don't have water. We don't have enough water supplies. So that's for Melbourne, but if you look at all the other cities, I said before that we were experiencing drought conditions since late 1990s. So this graph shows the supply and demand in major cities in Australia in 2001-2002 financial year. As you can see, that the green line is the unrestricted water demand. So that is, if you are not restricted, that's how much water you would use. And the blue bar is the yield available from your sources. As you can see, some of the cities like Sydney, demand is much more than the water available for that city. This is in 2001-2002 financial year. And it's the same for Melbourne. And in most of the cities, basically, we were running out of water at that time, 10 years ago, running out of water. Everyone was panicking, so everyone was looking for solutions. So our water system is mainly, at that time, we take water from surface water dams, we treat it, we use it, and then we generate wastewater, and that goes into wastewater treatment plants, and then we generate stormwater from urban areas that's untreated, goes into the ocean because all of the cities are along the ocean. But, so what were they looking for as a solution is integrated approach. So they were thinking that, okay, now we are losing a lot of water. Can we use this stormwater and wastewater as sources? So as you can see, it was really about integrated urban water management, looking at alternative sources and also trying to reduce the demand, which makes the system more complex with all these flow paths compared to that linear system. So when we were seeking for alternative sources, so this graph shows basically the supply and stormwater and wastewater generation in each city. So if I take Melbourne as an example where I live, the yellow bar shows the water supply. That's how much water we need. And then how much wastewater that we generate is the green bar. So almost, I said that about 40% of the water is used outdoor, so therefore 60% of your indoor supply converted into wastewater. And then we generate because lots of hard surfaces, we generate a lot of storm water. So if you look at this graph, you'll see that, okay, we have some alternative sources available in the city. Can we use these sources? This is a possibility of recycling wastewater and the possibility of harvesting stormwater and using them for purposes that are fit for this water. And so this concept had been embraced by water utilities around Australia, not one city, because we were running out of water, 10 years ago. So what these two showing is that the bottom graph is showing this is like, if you look at water strategies, so in Australia, every water company has to develop a strategy, water strategy, so which shows, how you're going to supply your demand for the next 20 years, 50 years, so it's like the outlook. So in 2005, this is basically showing, what are the portfolios of water, what are the sources being considered by utilities. And as we go to 2007, what I'm trying to show here is that, the embracement of this source diversification. So every city is considering the use of alternative water sources. That's really the key point about these two bar charts. So we were looking at many sources coming from decentralized sources like rainwater tanks, to stormwater harvesting, wastewater recycling, desalination, and demand management. So groundwater and surface water are mainly traditional sources. So there was because we were running out of water, every city was panicking, so they were looking for some silver bullet solutions. So they all went for desalination because that's the easiest one to do. It's most costly, but it's easy. And the other thing is that it's not complicated because all the other water sources, we need to figure out whether they are suitable for public health use, and there are other issues associated with other sources. But with desal water, you take salt water and desalinate, and then you can inject into your centralized system. Less complicated. So every city went for a desalination plant. Not every city, most of the major cities. So some major cities now have desalination plants. What did it do? It actually secured our water supply for the next 10 to 15 years. So we can say that, for some cities, there is no water problem now because we have additional water. But there is a strong interest for using rainwater, recycled water, and stormwater. And there's a lot of research is happening to understand the issues around how to use this water more effectively and efficiently. So with regard to stormwater, the key issue is how to store stormwater. So it's like, stormwater is available when it's raining, and we don't use stormwater when it's raining. We have our dams full. So you have to have place to store this water. And all of these urban areas, they don't have, open spaces to put more dams or ponds in cities. So we're thinking of, storing water underground. So what we call it managed aquifer recharge. So you collect water, you treat it naturally using a wetland, and then you inject it to the ground and keep it for a certain period of time, and then you retrieve that water for usage. And our research showed that it can even drinkable, that water. It's of drinking water quality. But there is no acceptance for drinking that water in Australia. And recycled water, so if we look at the recycled water from 2005 to 2012, there is increased trend of using recycled water. It says that once you do tertiary treatment, it's suitable for drinking, but there is no acceptance for drinking of treated wastewater in Australia. And the other key source we use is rainwater tanks. And what this graph showing is that, every city got many number of rainwater tanks now. So, there was some rebates given for installing rainwater tanks in houses, and for using it not only for outdoor usage, but also for toilets and hot water, and for cloth washing, and for garden use, which actually can take about 30% of your household demand can come from rainwater tanks if you do it effectively. And source diversification. So this whole concept is what we call source diversification, which is a principal concept of integrated water management. So what it does is not only providing additional supplies, but it also got other additional benefits too. What this graph showing is that, there's a lot of nutrients and sediments get generated from stormwater. And all of this stormwater, when you discharge that stormwater into receiving water bodies, we basically disposing a lot of nutrients and sediments into water bodies. So the urban areas, as urbanization happens, we make more urban areas, so that means more nutrients and more sediments would get discharged into receiving water bodies. So by capturing stormwater and by using wastewater, we are actually reducing the amount of these nutrients and sediments going into receiving waters, which is a good thing. And it will protect aquatic ecosystems, and you will have nice waterways around your city, so it's all good. So all I talked about is, I said we had a problem, water supply problem, and we brought in integrated water management as a solution, and we embraced that concept, and all of the cities got now not a single source of water, it's a portfolio of water. But despite all these benefits, we now got lots of challenges. What this picture showing is the Southeast Queensland, which is where the Brisbane is, Southeast Queensland water grid. So we brought all these sources, we make the water supply system more complicated now. Now, if we look at the Southeast Queensland water supply system, it got all of these features shown in the green boxes. It got reversible pipe connectors, it got hydropower, urban agricultural uses, it got surface and groundwater were the traditional sources, and then we brought in desalination plant, we brought in advanced wastewater treatment plant for recycling, and at local scale, we got rainwater tanks in individual houses, and at neighborhood scale, we're using stormwater. So we're bringing all these additional features and making a water grid much more complicated. So one of the key challenges in this city is to make how to operate this grid in an optimal way. Because what this means is that once we bring in all these sources, we increase pumping because we bring desal water, which is in coastal areas. To bring that water upstream, you need to do a lot of pumping. So there is a problem of how do we operate this system more effectively and more efficiently. And as I said before, some sources operate at local scale, some sources operate at centralized scale. How do you do this integration? How do we fully understand the system implications of bringing all these sources? So, and also we need to have community support for all of these things. If we're spending a lot of money for the operation of this system, the community and the government going to say that, oh, this is a white elephant, we don't want this. Why did we build this? So there are questions being asked like that. So there are challenges. So what I'm trying to say is that we found a solution, we adopted it as a mitigation measure for climate change, but there's a whole lot of challenges that we're facing now. So they are the things that need more research to understand this type of system. So in CSIRO, we do a lot of research in these new systems. For example, for rainwater tanks, we're looking at whole lot of issues, trying to understand the yield, trying to understand the energy use, what's the acceptance for rainwater tanks, and what's the quality of water coming from these tanks. So it's a whole lot of things you need to understand. And similarly, we also spend time and money on what we call integrated system modeling, which is to model the whole urban water system from supply catchments to demand to receiving waters in a one big modeling system. So in Australia, there's a new modeling platform developed. It's called eWater Source Integrated Modeling Platform. You can Google that, then it will give you a whole lot of information about this modeling system. So this type of modeling system can be used to understand what is the best mix of water sources if you are given a whole lot of water sources, and what is the best time to augment. Is there is there a better way of putting these sources? Is there a better location for different sources? So you can ask a lot of questions once the system is set up for the city. So this is a city scale model. So with that, come to my last slide. So what I tried to show from my presentation is that climate change has a significant impact on urban water supplies. It's not only for urban water supply, but also for stormwater and wastewater, but I was focusing on urban water supplies. And we actually experience the possible implications of climate change over the last 10 years. So we know what it is now. So if it is like a warming climate, drying climate, this is what we're going to experience, the same thing. So we adopted integrated water management as a possible solution, as a possible adaptation measure. It worked, but it also created a whole lot of other issues and challenges. So I think the challenge now is to address, now we have water, most of the cities have got water, we don't have water problem now. So therefore, it is now the time to do more research on these alternative sources and understand what their implications are, how to make it more acceptable to the community. So the cities cities understanding that there's a lot more funding is making available to integrated water management in Australia. Thank you very much.